Dear students, welcome once again to Army Public School PMA Resource Network. Before we start our today's subject, Maths, please subscribe this page and click on bell icon to receive the upcoming notifications of our channel. This video is about the rational numbers, a lot of examples, and their uses. In this module, we will learn to recognize and define a rational number and to perform arithmetic operations on fractions and decimals. We know about the natural numbers, whole numbers, and integers. But what are the rational numbers? Let us see. In real life, there are situations when we are required to deal with parts of a whole, or fractions as they are called. For example, parts of a pizza, measuring height more accurately, in this case 1.5 meters. Calculating the fraction of a difference in time in a very close race. Specific measures of ingredients in a cake recipe, and so on. So, any and every number that can be practically think of in real world, which can be denoted as a fraction or in a decimal form. What are these numbers called? Let us see. The word rational arises from the term ratio. A ratio like 5:2 can also be written as 5/2 is a rational number. Similarly, the ratio of two integers p and q, in which q is not equal to 0, can be written as p/q. This is the form in which rational numbers are expressed. A rational number is defined as a number that can be expressed in the form p/q, where p and q are integers and q is not equal to 0. For example, 1/3 is a rational number because it is in the form p/q and q is not equal to 0. -9/5 is also a rational number because p is equal to -9 and q is equal to 5, and both are integers. Similarly, 13/2 is also a rational number. These numbers are in the form of quotients or fractions. That's why the set of rational numbers is denoted by Q. Now the question is, are integers also rational numbers? Let us see. All natural numbers, whole numbers, and integers can be written in the form p by q by taking their denominator 1. For example, 7 can be written as 7 by 1. Minus 12 has denominator 1. And 0 can also be written as 0 by 1. So, all the natural numbers, whole numbers, and integers are rational numbers. Since we have just proved that all the integers are rational numbers, now a question might click our mind that whether are all the fractions rational numbers? Let us find the answer. As we know that fractions can also be expressed in the form of decimal numbers. For example, 7 by 8 can be written as 13.5 and 81 by 6 as 0.875. We can see that both 13.5 and 0.875 are the terminating decimals, and 4 by 3 can be written as 1.33 and so on, and 9 by 11 as 0.8181 and so on. We can see that both these decimals are non-terminating. In the number 1.33 and so on, 3 is recurring, a repeating digit, and in 0.8181 and so on, 8 and 1 are recurring digits. All the fractions which have terminating are non-terminating but recurring decimal representation are known as rational numbers. And what about the non-terminating and non-recurring decimals? For example, we have a fraction 1 over square root of 2, which can be expressed as 0.7071, 0.67812 and so on. We can see that this is a non-terminating decimal and none of the digit is repeating or recurring. Here, note that all the fractions which have non-terminating and non-recurring decimal representation are not rational numbers. Hence, we can say that rational numbers comprise of the entire set of integers and fractions. An important thing is that the fractions which have terminating or non-terminating recurring decimal representation are included in the set of rational numbers. Now, let us talk about fractions, mixed numbers, and decimals. First of all, let us revise fractions. A fraction is a part of a whole. It represents one or more equal parts of a whole object. Look at the fraction 3/4. The number above the line is numerator. It indicates the number of equal parts considered. The line is called fraction bar or division bar. and the number below the fraction bar is called denominator. It indicates the total number of equal parts the whole is divided into. Now, let us revise the types of fractions. 1. Proper fractions. A fraction in which numerator is less than the denominator is called a proper fraction. For example, 2 by 8 is a proper fraction because 2 is less than 8. 2. Improper fractions. A fraction in which numerator is greater than or equal to denominator is called an improper fraction. For example, 5 by 2 is an improper fraction because 5 is greater than 2. And 2 by 2 is also an improper fraction because 2 is equal to 2. Next, mixed fractions. A mixed number, also called mixed fraction. It is the sum of a natural number and a proper fraction. For example, 2 whole 1 by 2, where 2 is a natural number and 1 by 2 is a proper fraction. Did you know what are like and unlike fractions? When two or more fractions are given, depending on the value of their denominators, they can be termed as like or unlike fractions. Like fractions. Fractions with the same denominator are called like fractions. For example, 1 by 4 and 3 by 4 are like fractions. Unlike fractions. Fractions with different denominators are called unlike fractions. For example, 5 by 8 and 5 by 3 are unlike fractions. Now, let us discuss arithmetic operations on fractions. While adding or subtracting like fractions, we just need to add or subtract the numerators accordingly by keeping the denominator same, and then simplify when it is possible. Let us see an example. We have an expression minus 1 by 2 plus into minus 3 by 2. In first step, the two signs positive and negative, which are appearing together, will merge into a negative sign. Now we can see that these two fractions have same denominator. So here we just have to add the numerators because both numbers have same sign. We will get minus 4 by 2, which can be simplified as minus 2 because we know that when a negative number is divided by a positive number, we get a negative number. Here is another example of subtracting like fractions. We have an expression 3 whole 1 by 8 plus into minus 1 by 8. First of all, we will merge the signs by using the rule plus into minus. is equal to minus. In the same step, we will convert mixed number into an improper fraction. Now since these two fractions are like fractions, so we will subtract the numerators because both numbers have different signs. Then we will get 24 by 8, which can be simplified as 3. Next, while adding or subtracting unlike fractions, first we need to find the LCM of denominators to make equivalent fractions. Then we will add or subtract accordingly by keeping the denominator same. And at the end, result can be simplified if it is possible. Let us see an example. Suppose we are given an expression like minus 3 whole 1 by 6 plus into minus 4 whole 2 by 3. First, we just need to merge the signs which are appearing together and convert these mixed numbers into improper fractions. Then we will make an equivalent fraction of 14 by 3 for having like fractions. Once we get the like fractions, we will add the numerators because both these numbers have same signs. Hence, we will get minus 47 by 6, which is an improper fraction. By converting this improper fraction into a mixed number, we are left with an answer minus 7 whole 5 by 6. Let us have another example involving subtraction of unlike fractions. Question is 5 whole 1 by 5 minus 4 whole 1 by 2. In first step, we will convert mixed numbers into improper fractions. Next, we will make equivalent fractions for having same denominator. So, we will get 52 by 10 minus 45 by 10. Now, since both fractions have same denominator, therefore, we can subtract the numerators. After subtracting, we will get an answer 7 by 10, which is a proper fraction. Now, let us discuss multiplication of fractions. Note that while multiplying fractions, it is not necessary that all the fractions must have same denominator. We just multiply across numerator by numerator and denominator by denominator. At the end, if the answer can be simplified, we will simplify it. Let us understand this concept through an example. For multiplying these two mixed numbers, we need to convert these into improper fractions, and then we will multiply numerator by numerator and denominator by denominator. After multiplication, we are left with a fraction minus 110 by 10, which can be simplified as negative 11. Next, when dividing fractions, again we do not need to have common denominators. To divide two fractions, change the operation to multiply and take the reciprocal of second fraction. Then multiply accordingly and simplify the answer if it can be simplified. Let us see an example related to division of fractions. We are given an expression 4 whole 1 by 6 divided by 5 by 2. First, we convert the mixed number into fraction. Then we change the division operator into multiplication, and for this we need to take the reciprocal of second fraction. As you can see, we get an expression 25 by 6 multiplied by 2 by 5. Now we will multiply 25 with 2 and 6 with 5. We get 50 by 30, which can be simplified as 5 by 3. And the answer will be 1 whole 2 by 3 when it is converted to a mixed number. Now let us revise the decimals. A decimal number can be defined as a number whose whole number part and the fractional part are separated by a dot. This dot in a decimal number is called a decimal point. Note that the value of digits get bigger to the left of decimal point and the value of digits get smaller to the right of decimal point. Now let us see how we can perform arithmetic operations on decimals. While adding and subtracting decimals, write down the numbers one under another by aligning the decimal point. Put in zeros if the numbers have not same length. Then add or subtract accordingly and put the decimal point in the answer at exact place where it is aligned. We have an example minus 6.7 minus 5.4. Since both these numbers have same signs, so we have to perform addition. For adding, write down the numbers one under another by aligning the decimal point. Then we will add them as we normally do and put the decimal point before 1 as it is aligned above. And we can see that both the numbers have same sign, which is negative, so the answer will also have a negative sign with it. See the next example, which is 2.8 plus into minus 1.5. First, we will merge the sign. Now look at this expression. We have 2.8 minus 1.5. Since both these numbers have different signs, so here we need to perform subtraction. And when we will subtract 1.5 from 2.8, we get 1.3. Since the greater number have positive sign, so the answer will also have a positive sign. Now let us discuss the multiplication. For multiplying decimals, we just have to multiply the given numbers as we normally do by considering that there is no decimal point in given numbers. In next step, we add up the decimal places there are in given numbers. We multiplied and put that many places in answer. We have an example in which 14.72 is to be multiplied with 1.2. We will multiply both these numbers by ignoring the decimal point. And now we can see 14.72 has 2 decimal places and 1.2 has 1 decimal place. Since we have total 3 decimal places in both numbers which we multiplied, therefore we will place the decimal point in answer so that we have 3 decimal places in it. And the answer will be 17.664. Next, for dividing the decimals, note that if the divisor is a decimal number rather than a whole number, then we need to take an extra step. In this step, we convert the divisor from a decimal number to a whole number. We do this by moving the decimal point to the right in the divisor until there are no more digits other than 0 to the right of decimal point. Then we move the decimal point to the right same number of places in the dividend. Next, the division will be pretty simple. Divide the number as we normally do using long division method and bring the decimal point directly up from the dividend. Look at an example. We have to divide 1.845 by 0.15. In first step, we move the decimal point in denominator or divisor 2 places to the right so that we can get a whole number. And for this, we must do the same with numerator. After this, we are left with an expression 184.5 divided by 15. Now we will perform division and bring the decimal point directly up from the dividend, which is 184.5. Before assigning you home task, I would like to share few points that you have to remember in order to do your assignments properly. Recognize a rational number as p by q. Remember to change mixed numbers to improper fractions while solving the questions. Make the denominator same when adding or subtracting fractions and then add or subtract the numerators, only keeping the denominator same. Remember to follow the rules for multiplication and division. And when combined operations appearing together in fractional questions, apply the rules of operations on them. This is your assignment related to chapter number 2. Solve these questions with proper steps and submit it on AIS. In week 7, you have to do practice nows from textbook page number 45 to 49. Then you will solve selective parts of questions from exercise 2D. Thank you for watching this video.